Hello, Honors Algebra students. Mr. Lawrence here. Here's the first of the two review videos. All right, I'm recording for this on Sunday, and I'll post it Monday, and I'll have the second one posted Monday, I hope, as well, at the latest Tuesday. Remember, I will be helping as much as possible after school this week. All right, here we go. First thing we learned was rate of change in slope, and we had this equation for slope. And remember that when you do it, you have to do subtraction. So if I want to figure out the slope for A, you might want to do this if you need to. Hopefully you're getting to the point where you don't need to do this all the time, but if it allows you to get it right, then you go ahead and do it. Okay. And so I'm just going to fill in the formula. I'm going to do -5, and I'm going to subtract -8 from it. Very common mistake there is to not put the subtraction sign in. All right, my denominator, this is going to be equals, by the way. My denominator is going to be -9 minus -3. Right, these will change to positives, and so will these, because minus a negative is like adding a positive. Numerator will be a +3. Denominator will be a -6, which will simplify to a -1/2. Now remember, the negative could have been in the numerator, could have been in the denominator, although that's very unusual. We don't like that in the math world, okay? But mathematically, it is correct. All right, and then the negative I put out front. They're all the same thing. Did I have to use this point as my first point? No, didn't have to. I could have switched the order of the points. I would still get the same fraction. The negative might have moved, but that doesn't change the value of the fraction. All right, here's two special cases. You can always go back if you need more problems like this. You could always make up some of your own, make up 2 points, try to calculate the slope, ask somebody to check it for you. I'd be happy to. Or you could go and do some of the study plans in the Math Excel. All right, B and C are special cases. Why don't you pause the video, see if you can figure out what they are, and when you're ready, unpause the video and you'll see my solutions. All right, B ends up having no slope, because when I subtract my x's, I get a 0. So I get a fraction like this. All right, it doesn't matter what the numerator is if the denominator is 0. The numerator will end up either being 10 or -10 based on which point you call the first one, but it doesn't matter because we can never divide by 0. You could tell me that this slope was undefined, or you could tell me that there was no slope. Either answer is acceptable. This explains that we can't divide by 0, and this specifically talks about slope. Okay, but either one is acceptable. So, C, hopefully you've tried C. If you haven't, pause the video and try it yourself. Here comes my solution. M is actually going to equal 0. Yeah, because when I do -3 minus -3, those become positives, and so my numerator becomes 0. All right. Now, as long as my denominator is not 0, the fraction will simplify down to 0. If my denominator is 0, then it simplifies to, well, it doesn't simplify, it becomes undefined. All right, so I'm going to have a -5 minus 4. That'll be -9, which is the same as 0. Remember, 0 slope doesn't mean it doesn't have slope. A line with 0 slope is a horizontal line every single time. That's not a very good horizontal line, sorry. Something's not right with the airliner. It just doesn't work like it used to. I can't even get my subtraction to, or my eraser to work there, so let me try this. If you plotted those 2 points and connected them, you'd get a horizontal line. On B, if you plotted the 2 and connected them, you'd get a vertical line. I know they don't have arrowheads, but I'm not going to get bent out of shape over it. All right, so direct variation. This is the second thing we learned. If y varies directly with x and y equals 8 when x equals 10, find y when x equals 12. Well, remember, direct variation means the two terms are proportional. And there's an equation, right? The equation is y equals kx. Any form of that equation would also be direct variation. So if I, for example, wanted to get k alone, I could divide both sides by x, and I would get y over x, right? If I wanted to get x alone, I could divide both sides by k, and I could get y over k. All right, just manipulating the equation. This is usually the one we work from, but all three of these are just like d equals rt. You can manipulate it to solve for one of the variables. Direct variation means that one of the points will absolutely be the origin, right? It kind of looks like slope-intercept form, except the y-intercept is guaranteed to be 0 if it's direct variation. So how do I do a problem like this? Well, I'm told that x is 10 and y is 8. So I'm going to fill those in, substitute those in to my equation y equals kx. And I'm going to solve for k. When I do so, I'm going to get 4/5, right? Because 8/10 will simplify to 4/5. All right, or you could tell me k was, 8/10, like that, right? And then I'm going to use the equation again, y equals kx, but I'm going to use it with the new numbers. See, I'm told x is 12, right? X is 12. I'm told that k is 8/10, and I'm going to go decimal on this one. It's going to be a little bit easier, and so I have to find y. All right, so y, I believe, is going to be 9 6/10. Is that right? I think that is 9 6/10. And that's the value of y when x is 12. Okay, now I made a little sketch graph, not of this problem, just of a direct variation situation, pointing out that one of the points has to be the origin, right? Here's your x values, and here's your y values. Direct variation is linear. It's a linear equation where the origin is one of the points. All right, has to be. Okay, and it also, by the way, means that x and y are proportional to each other. Okay, so let's move on to graphing here. And we're going to speed things up a little bit. So graphing from slope-intercept form. Remember, slope-intercept is y equals mx plus b. And remember that the y must be alone. If y is not alone, then you're not in slope-intercept form. You might have to manipulate it. So I'm not going to do a real simple one. I'm going to do one where we have to do a little bit of work because I'm trusting you already know how to do the simple ones. Sorry, I'm having some trouble here. As I mentioned, this airliner is all over the place. So let's go with 3y. It's going to equal negative 5x plus 12. All right. Now, since y is not alone, we're not in slope-intercept form, so I have to manipulate it. I'm going to divide by 3. Remember, you must divide all the terms by 3. And so my equation is going to turn out to be, let's see here, y equals negative 5/3 x, that's supposed to be a 3 down there, doesn't look very good, plus 4. So my y-intercept is the point 0,4, and so I'm going to plot the point 0,4, right? And then my slope is negative 5/3, and so from 0,4, I'm going to count down 5, rise negative 5. So I think that would be that, and then run 1, 2, 3. All right. Now, the other point, if I want another point, I could change the signs. I could rise positive 5 and run negative 3. And look at that. All three of those points would be linear. Of course, I only need 2. The more points I put on there, the more accurately I can draw my line. So I'm actually going to go 2, 3, 1, 2, 3, 4, 5. So I'm going to start down here. And you can see that they are all on the same line. I'm hitting the line there. And I'll put an arrowhead on the start. And there we go. All right, that's slope-intercept form. Had it said like y minus 5 instead of 3y, I would have added 5 to both sides. All right, point-slope form. And remember, point-slope form is just a special version of the slope equation, right? It says y minus y sub 1 equals m times the quantity of x minus x sub 1. All right, so if I had an equation like this, y minus 6 equals 2 times quantity of x plus 4. The first thing I do is identify my point, and remember the signs change. It'll be negative 4, positive 6. And then my slope is going to be the value of 2 over 1, my rise over run, 2 over 1. So I plot the negative 4, 6. Where'd you go? Negative 4, 6 is right there. And then the slope tells me to rise 2 and run 1, like that. And so I'm going to rise 2 and run 1 again. All right, so get my line like that, and maybe I'll extend it a little bit. I'm sure there's a setting I could change, maybe the scroll rate or something, I'm not sure. Okay, and properties. Okay, so there's that point slope form. All right, now we also learned about standard form. And remember, standard form is ax plus by equals c. And a couple of things are happening here. A is greater than 0, right? A is positive, okay? And we're going to want it with integer coefficients. So I'm going to do it with integer coefficients too. So I'm going to do two problems. I'll actually do them on the same graph. So let's say I have 2x minus 4y equals, I don't know, 6. Okay. Now, the first thing I want to do is I want to identify A, B, and C. So in this one, it's A, B, C. Easy as 2, negative 4, 6. Okay, and remember I have some shortcuts. To find the x-intercept, I can do the point C divided by A, 0. To find the y-intercept, I can do the point 0, C divided by B. And then to do the slope, I could do the negative of A over B. All right, now I only have to do 2 of these 3. In fact, as I look at it, I don't like the y-intercept because it's not going to come out to be an integer. It's going to come out to be a rational number, a fraction. So I'm going to find the x-intercept. I'll find all 3, but I'm only going to use the x-intercept and the slope. So the x-intercept is going to be c over b, or 3, c over a, excuse me. 3, 0 is my x-intercept. My y-intercept is going to be 0, and I believe it's going to be negative 1.5. Now, graphing negative 1.5 isn't that hard to do, but if I could be at an intersection of 2 integers, it's a little bit easier. So my slope is going to be the negative of a over b, or better yet, just plain old 1/2. So let me go up here and plot my 1 point, and that's going to be 3, 0. There we go. And then from there, I'm going to rise and run. Rise 1, run 2. Right? And I'm going to rise 1, run 2. Okay, so now I'm going to draw my line. And you remember me saying that the y-intercept was going to be at 0, negative 1.5? If you take a look at my line, you can see, even though it's a little bit inaccurate, it's still crossing right about there. If I drew a better line with, on pencil and paper, it would be crossing exactly at negative 1.5. 0, negative 1.5. All right, so let's try another one here. This time, let's make it so that there aren't integer coefficients. And we'll get it into standard form and use the integer coefficients. All right, so let's see here. Okay, so our new equation, our new equation, this time, I'm going to leave that line on there. It won't hurt anything. Is going to be negative 1/3 x plus, let's go minus this time. Let's go, oop, that's going to be way too big here. Yeah, let's go with minus 2/5 y, and we're going to have that equal to, yeah, I guess we'll go 1. I think that'll work out okay. Now, they aren't integer coefficients, so I'm going to multiply each term by a number that will get rid of all my fractions. I think that number is going to be 15. The least common multiple of all the denominators. I'm going to multiply by 15 over 1 to the 1 to the 2/5 y and to the 1/3, negative 1/3 x. You know what? Maybe I should multiply by a negative. That'll make a positive, won't it? Yeah, so I'm going to multiply by a negative. All right, so when I do that, my new equation, well, it's not really a new equation, is going to end up being 5x, 5x, and those two negatives are going to cancel there, so I'm going to get plus 6y, I think, because 5 is going into 15 3 times. 3 times 2 is 6, 6y, and that's going to equal negative 15. I can tell you I don't like my y-intercept again. I do like my x-intercept, and I'm going to use my slope. All right, so anyway, my x-intercept, or wait, a, b, c, easy as 5, 6, negative 15. All right, so my x-intercept is going to be negative 3, 0. My y-intercept is going to be 0, and 15 over 6. I think that's negative 2.5. Okay. And then my slope is going to be negative a over b. So let me plot this in a different color here. Properties, change color of him, something uniquely different, and there we go. And we'll clone him. All right, so we're going to have negative 3, 0. Okay, and then my slope is negative 5, 6. We're down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right? And then we could always go up 5 and back 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There you go. And that's going to produce our other line. Notice that positive lines look like they're going up to the right, and negative lines look like they're going down to the right. Sorry, the lines aren't actually positive or negative, it's the slopes. All right, I'm not sure what just happened with my computer there, but maybe that's a warning sign that I should stop for the night. So I am going to take that as an omen I should stop, and I will say good luck. This was the end of part 1, and part 2 will cover the last few sections of chapter 5, parallel perpendicular, graphing absolute value equations, and maybe some things with functions like f of x and g of x, that kind of thing. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.